Fourth graders, today is Thursday, October 3rd, and we are combining two Go Math lessons today. Okay, we're doing 5.2 and 5.3 because they're very related. And both of them are about teaching you how to explain whether one number is a factor of another number or not. Okay, so if I give you a number, you have to tell me if it's a factor of another number, and I'll tell you how to do that. On yesterday's exit ticket, there was this question. If 8 is a factor of a number, what other numbers must also be factors of that number? So if there's a number where 8 is a factor, okay, what is a number where 8 might be a factor? Like 16, right? Or 24, 40, 80, 88, right? 8 is a factor of a number, okay? We don't know what the number is. It doesn't really matter. The question is asking what other numbers are going to also be factors. Some of you wrote this. 16, 24, 32, 40, etc. Is that correct? Why or why not? Go ahead and talk at your table groups. These numbers that you guys all wrote down, those are not factors. Those are multiples of 8. Okay. So going back to the question then, what other numbers must be factors? If 8 is a factor, what other numbers must be factors? Well, what are some factors of 8? 2 and 4, right? Or also 1. So if it is a factor of 8 and 8 is a factor, then the factors of 8, 1, 2, and 4, must also be a factor. Some of you did get this right. And there's someone at each table group who did get it right. So if this makes a lot of sense to you, I want you to explain to your table group why that is. Go. At the top of page 5.2, whatever page number it is, it says, students in Carlos's art class painted 32 square tiles for a mosaic. As we know, mosaics are pieces of art made from lots of small tiles, yes? They will arrange the tiles to make a rectangle. Can the rectangle have 32 tiles arranged in 3 equal rows without gaps or overlaps? Can we? Can we make 3 equal rows? Let's try. 3. Go ahead and try in the box there. It says, try to arrange the tiles into 3 equal rows. So I'm going to go 1, 2, 3 down. And then how many across would I need to have to make 32? Let's see, if I put 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many tiles would I have used up? 10 times 3 is? 30. Oh, that's not going to work. Could I do 11? Let's try 11. Times 3 is 33. That's too much. So can I make a rectangle using 3 rows? Does it work? Does it work? No, because I either have 2 extra or 3 or 1 less, depending on how you look at it. So a rectangle can or can't have 32 tiles arranged into 3 equal rows. What's the word that fits there? Can't. So what does that tell us? Is 3 a factor of 32? No. Therefore, 3 is not a factor of 32. So one way you can tell you should be drawing, come on, where's your picture? One way to tell if 3 is a factor of 32 is by drawing a model. If you can't draw the model, then it's not a factor, okay? Another way is by using division. If 3 is a factor of 32, then we can use math facts. We can divide and say, oh yes, it will work. Let's divide and see. We have 32 divided by 3. What's 3 divided by 3? 1. Okay, what's 3 times 3? 1 times 3? 3. What's 3 minus 3? 0. Okay, we're going to bring down the 2. What's 2 divided by 3? 0. We can't do it. What's 0 times 3? 0. What's 2 minus 0? 2. So we have a remainder. 10. Remainder 2. You guys learned how to do this in 3rd grade, yes? Yeah. Okay. So the unknown factor of 3 times blank equals 32, is it a whole number? Is it a whole number? No, it's not. So a rectangle can't have 32 tiles arranged in 3 rows. If the answer was a whole number, then it would have been a factor, okay? So what you're doing in the second way is you're dividing to see whether or not the unknown factor is a whole number. If it is a whole number, then it would have been a factor. A factor of a number divides the number evenly, right? Think about it. If 3 is a factor of 6, it's because it divides it evenly into 2 parts. 6 divided by 3 is 2, which is a whole number. If the remainder had been 0, it would have been a whole number. Was our remainder 0 here? What was our remainder?
2.
So is 3 a factor of 32?
No.
No. One way you could tell if 4 is a factor of 30 is you could try to draw a rectangle with 4 rows, right? If you could draw a rectangle that has 4 rows, 1, 2, 3, 4 rows, and it could make 30, then it would be a factor. You could try to make a model. Another way is to divide 30 divided by 4. If it was a whole number, then it would be a factor. Try one of those 2 ways and tell me thumbs up if 4 is a factor of 30 or thumbs down if 4 is not a factor of 30. Another way to tell if something is a factor, really quickly, of another number is by thinking about divisibility rules. Everyone say divisibility.
Divisibility.
A number is divisible by another number if the quotient or the answer is a whole number and the remainder is 0. Okay, a counting number means a whole number. So some numbers have a divisibility rule. For example, we know if a number is even, 2, 4, 6, 8, 10, 12, etc., it must be divisible by 2, right? So that's how you can really quickly tell if a number is even, then it is divisible by 2. What does that mean? If a number is even, what number must be a factor of it? Is 14 an even number? That means it's divisible by 2. That means 2 is a factor of that number. 2 is a factor of 14. Does that make sense? Is 26 an even number?
Yes.
That means it's divisible by
2.
So what number must be a factor of 26? 2. Good. Is 536 an even number?
Yes.
It's a big number, 536. It's even, which means it must be divisible by
2.
which means what number is a factor of 536? Good. Okay, now you guys get it. Good. 2 is not the only one that has a rule. That makes it easy. The number 3, to find out if something is divisible by 3 or not, all you do is you add up the digits, okay, the sum of the digits. For example, the number 12. The sum of the digits would be 1 plus 2, which is 3. Is 3 divisible by 3? Yeah, which means that 12 is also divisible by 3. You see how that works? Let me show you another example. If I have the number 5,124. If you want to find out if that number is divisible by 3, all you need to do is you add 5 plus 1, which is plus 2, plus 4. Is 12 divisible by 3? So this number, 5,124, is also divisible by 3. That's just a rule that works. So 5,124, is it divisible by 3? So what number is a factor of 5,124? 3. What number also is a factor of 5,124 based on what we've learned? 2. Because it is also a even number, which means it's also divisible by 2. Do you guys see that? You guys know this one too. If the last digit is 5 or 0, then that number must be divisible by
5.
You guys know that, right? Which means if the last number, let me change this number now. Is that number divisible by 5?
Yeah.
How do you know? Has a 0 at the end. Is that number divisible by 2? How do you know? It's even. Is that number divisible by 3? How do you know? Because 5 plus 1 plus 2 plus 4 plus 0 equals 12, which is divisible by 3. So what are 3 numbers that must be factors of this number? 2, 3, and 5. 1 is always a factor too. So 1, 2, 3, and 5 so far. Okay, let's look at the next one. If a number is even and divisible by 3, that means it is also divisible by 6. Is this number also even and also divisible by 3?
Yes.
So what does it also need to be divisible by?
6.
So what's another factor of this number?
6.
Good. See how cool that is? 9 is cool too. 9 is just like 3, except it needs to be, when you add up the digits, it has to be divisible by 9. Okay? So 5 plus 1 plus 2 plus 4 plus 0 is 12. Is 12 divisible by 9?
No.
So is this number divisible by 9?
No.
No. So is 9 a factor of this number? No. If a number is divisible by another number, that number is a factor of the number. Make sense? These are things you need to memorize, okay? These are things you just need to know. Like, you know, even numbers are divisible by 2. How did you know that? You just memorized it. So the rule for 3, 6, and 9 may be new to you, so you need to memorize them, okay? It says Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. He wants to arrange the coins into rows. Each row will have the same number of coins, and all the coins in a row will be the same. So he's only going to put pennies in one row, or quarters in one row. Does that make sense? Okay. He wants to know how many coins he can put in each row. Okay. Could he put 36 coins in each row? Why not? Because he only has 30 pennies and 24 quarters. Does that make sense? Okay. Could he put 24 quarters or 24 coins in each row? No, because then he'll have 6 pennies left over, and he won't have enough to make another row. Does that make sense? So we want to find out, go ahead and underline what the question's asking. How many coins can he put in each row? The important information is that he has 30 pennies, 24 quarters, and 36 nickels. Okay, he wants to have each row to have the same number of coins, and all the coins in a row will be the same. Okay, so once we know what the question's asking, if you can understand what the question's asking, you should be able to explain it in your own words. So right now at your table group, explain what the question's asking us.